What is going on, everybody? Welcome back to my channel, Love Crypto. If this is your first time joining me, please consider hitting that like button. Consider subscribing to my channel. I hope you guys find this content very useful. I am your host. Today is Friday, February 16th, and today's presentation is going to be on resource allocation on EOS. There are 4 different topics I want to quickly cover. This is not meant to be an extensive review on the topics. I'd recommend everybody actually watch Dan's video on this, but this is my own Cliff Notes type of presentation for this, and helping me to understand it as I work towards refining my presentation skills for local Arizona presentations for EOS community. So 4 topics: bandwidth, RAM, storage, and voting. And before I go forward, I want to say a couple things. First and foremost, this content is prepared by me, by also review and suggestions by the community. It does not represent the thoughts or input from Block 1, who is engineering the software itself. This is just my own information. So do your own research. This is not meant to be investment advice. You guys already know that. But yeah, just wanted to mention that. So again, there are 4 different resources generally I want to talk about today on EOS.io in regards to, people have asked, what can you do with your tokens? What do they actually represent? So there's 4 different things we want to cover today in a very succinct manner. We're not going to ramble on, and we're not going to also make it too high level. So I want to make sure everybody understands what each of these properties means. First one is bandwidth, and normally the metric that we're talking about there is, how many transactions can you actually process per second, okay, across the network. That's what that is. And we're going to provide some analogies to help understand what that actually means. There's also storage, which is your long-term data storage. And, typically the metric there is the size, right, in bytes. So how many files are you able to save onto the network? Then you have your RAM computational capabilities, and this is really your working application memory, and this will also be in the form of bytes. But unlike your long-term data storage, this data is typically being used by applications like currently running and doing some type of computations. So if you compare the two, RAM is typically less because it's working memory. It's actually data that is being used in the current form to do some type of decision or processing. And then there's the evolution of the chain, which is the voting aspect of the token. And that's really the influence that you might have on the network to make key decisions which may drive value or adoption for EOS.io in the future. So bandwidth on EOS.io, I want to give a formal definition of bandwidth. I know some people kind of roll their eyes or go to sleep on this stuff, but I think it's important for people to know what we actually mean by this so you actually understand what the software does, what you're allocating tokens to. You can't do that if you don't understand what the technical aspects of this actually mean. So the general definition of this would be the data rate, the rate data can be transferred to or from the network. And key takeaway here is users of EOS can place their tokens into a bandwidth, what's called a staking contract. So this just means you take your tokens, you put them in a contract, they're locked there. It provides you then the ability to gain a fractional reserve of the overall network bandwidth capacity based on the total number of all tokens staked to that bandwidth contract, if that makes sense. So if you think about it, here's a very easy example for you guys. If there were, and this is not true, but if there were 100 users, each with an equal amount of tokens, and all those users decided to put all 100% of their tokens in that network, each person within that platform would have 1% of the network bandwidth, basically guaranteed bandwidth they could use for the purposes of pushing transactions to and from the network. Now, a contract owner can also delegate bandwidth to a user outside the contract to make things from a bandwidth perspective free to the user. So if someone doesn't have available bandwidth and it happens to be that the network is in high demand where there's no extra bandwidth capacity or free available capacity, non-guaranteed. The contract owner has the ability to delegate bandwidth to the user to help facilitate transactions across the network. The other important thing I think that I got from the cliff notes I took from Dan's video is that there's a 3-day delay in receiving tokens back from the staked bandwidth contract. And this is to prevent double spend issues and speculative activities from users. So I gave a hypothetical example here of bandwidth for a user. And this is what we call the bandwidth dynamic capacity versus reserve capacity versus use capacity. So the line on the top would be like the free, quote unquote, available bandwidth capacity. And that's going to fluctuate dependent on the usage of users across the network. So as more users who have tokens and have allocated guaranteed bandwidth use that allocated capacity, this free available capacity could shrink down. The guaranteed bandwidth is what you put in, and it's a percentage of your staked tokens relative to others. And then you have the used bandwidth, which would be the amount you're actually using. So you ideally, you'd want to have margin between, I think, the guaranteed amount of bandwidth you have and how much you actually need. And so that's what this is attempting to show for everybody visually, for my fellow visual learners out there, because I'm a visual person. I like to see things like that as well. So hopefully that helps. Now, in terms of bandwidth on EOS.io, we already gave the definition, but I thought I'd share some perspective on legacy applications as I normally do. So, for a current currency, debit card type transaction platform, most of those systems would need around 20,000 transactions per second, believe it or not. Once they're up and running and they're very popular, that's how much you're looking at. For social media likes, for example, and a lot of this was, actually brought over from Dan's and EOS's presentations, and I recreated those on an Excel and formatted them, for the right color for this presentation I'm doing. But social media likes are around 52,000 likes, and that would translate to 52,000 transactions per second. And then you have your market exchanges, and that's around 100,000 transactions per second. So if you combine everything together, you're under 200,000 transactions per second, and obviously you'd have multiples of these. So there is high use, or there is a high value in bandwidth if you just look at that from obviously any platform or any application that wishes to build a DApp. That's a pretty high value on why bandwidth would be useful to them. Average users themselves may not have such a high need for those transactions. So that's something to keep in mind. And I should also mention that, and I didn't mention that, the overview on the token resources on EOS.io, this is telling you where you can actually allocate your EOS tokens. So I've already, we've touched on the bandwidth now, in which you can stake a portion of your tokens towards the contract to gain the resources for the bandwidth. And we've explained, how legacy systems could value that, or why it's useful to them and why they need it, okay, based on what we know today for their applications. Now, there's a couple different ways, this can work. Again, folks could have their bandwidth, or the contract owners of the platforms themselves could delegate the bandwidth to those users. So it's going to be interesting to see, what strategies these platforms use to ensure that their users have the ability to access and navigate their applications on EOS. So going on to the next topic, it's RAM on EOS.io. And RAM, for those that maybe aren't as familiar with computing, components, all RAM is, it's a place in the computing system where what I call working data, that is currently being used by the application is stored. So there's some kind of computation that is going on, and obviously, just like your brain, when you're remembering something in the immediate moment, you have a couple things going on in parallel, and you have those things in your mind, and you're thinking about them. Well, that's what RAM is, as opposed to a long-term memory in which you may need to recall it from a long time ago, and it may take time. Well, working memory is what we call RAM, and that provides the ability for the applications on the network to use the data they need to process and make decisions, or to process a transaction, right? So users of a network can place EOS.io tokens into the EOSIO RAM staking contract, which gives them a fractional reserve of the overall network RAM capacity. And that's, again, based on the total number of all tokens staked to the RAM contract. So it works very similar to bandwidth on EOS.io. But in this case, one important distinction is the contract owner cannot delegate RAM to others. And the other important thing is removing tokens from the EOS.io RAM staking contract results in that user getting the value back from the contract that they put into, but no more. So there's no capital gains event from this operation from the user perspective, which is actually pretty good, if you ask me. So hopefully no questions on that, but if you guys have questions, let me know. I will try to answer them as best as possible. Obviously, this news and this information evolves with time. I can also be slightly off, so consult multiple sources. But I believe I've done some due diligence here in preparing this content for you guys. So RAM dynamic pricing on EOS.io is one of the more interesting aspects of this platform. And the idea here, and Dan explained it, is they really want the first initial bytes and RAM, if you want to call it that, to be very cheap. And it obviously needs to approach infinity as the need for capacity goes from 0 to the maximum network storage capacity in terms of RAM, the RAM capacity. So what he mentioned is that they plan to use the same formula as the Bancor algorithm in this case. The current storage or the RAM capacity would be the reserve of the market maker, which is the 1% reserve ratio. And the network would pretend, obviously, there's 100 times of the RAM to establish the price of the first byte. Now, if you actually end up doing the math, or you play with like Excel and you plot this out, what you get is something similar to this. I mean, mine's very extreme, but you get like this, initially very cheap price per, like, let's say megabyte on $100 billion market cap. And then you get a big rise, on the tail end, on the end of this, as the I guess the capacity starts to reduce, or the amount of capacity starts to reduce. The other interesting thing that he did is he mentioned that it only allows each person or each address to buy once per day, I believe. I did have a couple questions on that, but I know that was very interesting, preventing obviously hoarding and other types of strategies here. And it's very again, the other thing to keep in mind here is that you can't actually delegate this to others. So that's another reason that kind of prevents people from doing potentially speculative activities with this valuable resource. And again, the reason why you would need this is to process your transactions, again, working memory type transactions. So let's talk about storage. That's the next topic. And the general definition here is storage is a place in a computing system where data is held for a very long time until it is needed at a later date by an application or user. Dan mentioned too, he's intending to make this content addressable. And block producers would allow each user to upload data, and block producers themselves would replicate between each other to obviously make copies of this. But one of the things that he mentioned is that this upload-download operation of files is done off-chain, so it's not done on the chain. And each block producer would independently monitor the upload-download bandwidth rates. So this, unfortunately, this shouldn't be here, this RAM icon, but this is, just I'm showing analogies here to what you have today on your mobile phones. So if we go back a little bit, just because I didn't mention it, but here you can see like an Android app, and you have your device, what they're calling device memory. And so your apps use, a certain amount of RAM, and you have only a certain amount free. And so this EOS.io operating system works very similar to that. That's why I kind of wanted to throw that in there for you guys, so you guys kind of understand the relationship between our, typical operating systems and how this blockchain operating system is going to work. And similarly for storage, you have a similar thing. So you have a limitation on how much storage your phones have, your mobile phones have, and similarly on EOS, there's a limitation on how much storage you might have, depending again on how you allocate your tokens, and you know, it all depends on how everything is configured. So the last resource is voting on EOS.io, and this is one I think is more fluid and is evolving a lot more with time, because a lot of these things are being developed as we speak, but I want to mention it. So, you know, the takeaway here is that voting is very important, and it was very apparent to me that Dan had taken good time to strategize and think through the game, you know, the game theory aspects of this. And I want to go over some of the points he mentioned. But before I start, you know, I just want to say, obviously, voting is an important component of this platform, because the decisions that, you know, the voting impacts the decisions, and the decisions impact the value and adoption of EOS tokens, right? So some examples of that would be, do we upgrade to hard forks? What pay are the community contract worker proposals? And, you know, which ones do we fund as a community? So those are all important things. It's extremely important. The one thing Dan mentioned that was really interesting, and that a lot of people didn't get initially, is the 6-month token lockup period, which is a 6-month delay to getting all tokens out of the staking voting contract, and a fraction of the tokens returned each week over the 6-month period after the request for tokens out of the vote contract. You can also delegate your voting by proxy voting, but the thing to keep in mind is, you know, a lot of people say, well, why do the 6-month token lockup? And the takeaway here is, you know, you want to prevent bad actors, or you want to prevent people from doing bad things. If there's a large user who has a lot of tokens, for example, they want to influence a vote, they, you know, would be locked out 6 months from accessing their tokens. And in the meantime, if they voted in a way that would, you know, damage the network, they would lose all those tokens. Or they would, you know, they would suffer the losses from the decision or the influence they had on that vote. So it is a way to counteract and provide measures to incentivize people, again, to vote in the best interests of the community. And I think it's a very genius, you know, it's a very good way to actually control some of that. I think there may be some other tools that they'll add there, but I am you know, the way I understand it, it actually sounds like a good idea, because the last thing you want is for some rogue individuals to vote on something, make a bunch of money or funds from it, and then not suffer the loss in stake. The one issue that does come up, and still has come up in my mind, is how to avoid fraud or influence on the network, how to avoid payoffs in voting. So that, I think, is still evolving, but wanted to share this with you guys in terms of the 4 components that make up the network, and, you know, some of the things that have been shared, at least at this time, with this. So with that said, I'm going to end it with the typical get involved. For those that don't know, there are a lot of roles here on EOS.io, as well as you know, other platforms. I try to keep it agnostic here, but I do like EOS, so that's why I'm allocating my time and staking my time into something I believe in. But you can find you know, roles for developers, roles for consumers, business professionals, and folks that want to support the network in other ways. You can find more information on that on EOS.io, and other resources as well here at EOS Talk. There's a DAC creators group as well. You can join EOS Opportunities, and you can join EOS on Telegram, where I am at on all of these channels. I'm here available Friday, and I'd love to chat with you guys, help you guys out. If you guys have any questions, I'll try to do my best to direct you to somebody who knows the answers. So with that said, guys, I hope you enjoyed this video. Please hit that like button. Consider subscribing to my channel. And until next time, I'll catch you guys later. Peace.